Unit 2, Lesson 5. To start off this lesson, go to page 62 in your workbook and work on the skills maintenance page. Now that we're back, okay, activity 1, substitute the given value for the variable and solve. Okay, so in number 1, we had x plus 50. We're going to substitute x is equal to 25. So we're taking that 25 and we're substituting in for x. So then that's saying 25 plus 50, which will give us 75. Oh, what is that? Okay, so 75. Number 2, w is equal to 50. We're replacing w with 50. So that, in that case, is saying 30 times 50. Okay, I know 3 times 5 is 15. But then adding the 2 zeros on top of there, 1,500. Okay, so number 5 there, and 250, replacing that in there. So that's saying 500 minus 250 to give me 250. Okay, working back then, number 2, putting 500 in for y, substituting that in, which is saying 500 minus 112, which is 388. Okay, and then finally, substituting 100 in for m. That's saying 100 divided by 20, which is equal to 5. Okay. Now, activity 2. Okay, use tables to answer these proportion problems. Okay, Rihanna works in a candy store, and she is mixing little chocolate pieces with hard candies to get just the right mixture. She keeps trying to get the right proportion of chocolate pieces to hard candies. Okay, so first situation. Rihanna's first try is 1 part chocolate. Okay, so number of chocolate pieces, 1 part chocolate to 4 parts hard candy. If she uses 40 hard candies, okay, so we have 40 hard candies, how many chocolate pieces does she need? We don't know how many chocolate pieces she needs, so we represent that with a variable. Okay, which we'll go ahead and we'll use x in this case. Okay, once this gets back up. Okay, so from there then, we had 1 and 4, and then 40 and x. Okay, we represent x again because we don't know that. So we're just going to take 1 over 4, set that equal to x over 40. Okay, using our horizontal strategy here, times 10, times by 10, because 4 times 10 is 40, so 1 times 10 is 10. Okay, so she needs 10 chocolate pieces. Okay, so then the next one, her second try, she has 2 parts chocolate. Okay, so she's changing up that ratio. 2 parts chocolate to 6 parts hard candy. Now if she uses 20 chocolate pieces, how many hard candy pieces does she need? Okay, so our proportion, we got 2 over 6 is equal to 20 over x. A couple routes you can go. Easiest route in my mind is our horizontal times 10. Times 10, x would equal 60. So 60 hard candies. All right, there's skills maintenance for today. Now, our objective for today, use substitution to determine a limited range of values for 2 variables. Okay, so we're going to be given, we've started talking about equations with variables. Okay, up to this point, before we've talked about equations this way, we've always had a blank spot. Okay, what plus 12 equals 22. Okay, you'd have a box there and you'd fill in a value. Okay, or you'd have just a blank spot, plus 12 equals 22. Now the only difference is we're placing that box or that blank spot with a variable. Okay, now above you knew it was 10. Okay, so in this case, when we just replace a with that to that box in that space, a is equal to 10. Okay, so, because again, if I plug 10 into there, or into there, or into there, it's just different ways of representing that unknown value. Okay, so we've also talked about writing general patterns. Okay, if you notice here, you got 2 plus 0 equals 2. Okay, Negative 10 plus 0 equals negative 10. I see that negative 10 and negative 10 are the same. Okay? 1/2 plus 0 equals 1/2. Okay? This is what we call our additive identity property. Okay? The additive identity property, okay, is if we take a value plus 0, it is equal to that same value. Okay? So just like above, we had, when we went through, those ones were in red, okay, because they were the same. That's represented by A. And then we always went through with yellow. Let's go ahead and use green. Okay, that was the plus 0. Okay, that's what we call our additive identity property, because whatever we add plus 0, it's going to be that same number. Now, use whole numbers to substitute for x and y in the statement x plus y equals 4. Whole numbers are our counting numbers. Okay, whole numbers we can include 0. Okay, so 0, and then like we count 0, 1, 2, 3, 4, 5, 6. That's how we count. Those are our whole numbers. Okay, so when I say 4, 4 is a whole number. So if I'm thinking I'm looking for a list of values, I can replace 4 in there. 4 plus what is 4? 4 plus 0 is 4. Okay, so then picking another x value, 3. Okay, again, 3. 3 plus what is 4? So 3 plus 1 is 4. And then if we were to pick 2, 2 plus what is 4? 2 plus 2 is 4. Okay, 1 plus 3 is 4. So again, when you are combining these, when you take the sum of those values, it should equal 4, because that left one is representing x, the right one is representing y. Okay, so we can go again. 0, like we said, 0 is a whole number. 0 plus what is 4? 0 plus 4 is 4. Okay, now that was whole numbers. Now if we start talking about integers, integers are going to include the negative values as well. Okay, all whole numbers are integers, but not all integers are whole numbers. Okay, so if we go the route of like 5, okay, 5 plus what is 4? You actually have to do 5 minus 1. So 5 plus negative 1 is 4. Okay, so 6 minus 2. 7 minus 3. 8 minus 4. Okay, so again, we had the equation x plus y equals 4. So when we combined all of these together, okay, each line, it should have came up with a total of 4. Okay, so like the top one, 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, 0 plus 4 is 4, 5 minus 1, 6 minus 2, 7 minus 3, 8 minus 4. They all equal 4, okay? And that's what we needed, because it had to follow that equation there. So we can substitute a single number in any number and a range of numbers for variables depending on the problem, okay? So apply skills, you'll look into that. So pause your video, go ahead, work on that page 63 and 64. All right, so now that we're back, activity 1, check the number of possible values that can be substituted for the variables in each equation so that the equation is true. So if x and y can be any whole number, again, those are our counting numbers, 0, 1, 2, 3, 4, 5, okay, in the equation x plus y, then there is a limited set of values for the variables, okay, because you can do like 0 plus 3, 1 plus 2, 2 plus 1, and you're stuck at that, okay, so it's a limited set. Now, if a can be any integer in the equation, negative 4 plus a equals 1, then there is exactly one value, okay? There's only one value that's actually going to give us the equation to be true, okay? Negative 4 plus 5 is 1. That is the only value that will let this equation be true. Okay, number 3, if x and y can be any whole number in the equation, x plus y equals 5, then there is a limited set because, again, whole numbers, so we can only use our counting numbers, okay? A lot of times, anytime you're dealing with just a whole number, it's going to be a limited set. Now, if a and b can be any whole number in the equation, okay, a plus b equals b plus a, then there is, okay, this one's a little bit different, there's an infinite number of values, okay? Because a plus b equals b plus a, so no matter what values we use, it will equal each other as long as a is a and b is b. Now, the difference between that one and the one up here is that we have it set equal to a specific value, okay? So that is why that one is a limited set. Okay. Now, if m and n can be any whole number in the equation, m plus n equals 12, this is a situation like where the x plus y equals 5, okay? We're going to have a limited set because it's set equal that specific value of 12. Okay, so go ahead and let's do a chart actually. So x divided by y is equal to 4. Okay, we need to show 4 examples. So, and we're going to use whole numbers. So like, let's just say I'm going to set x equal to 4. Okay, 4 divided by what is 4? 4 divided by 4. 4 divided by 1. 4 divided by 1 is 4. Okay. And if I want it to equal 4, I'm going to use my multiples of 4. Okay, so like 8. 8 divided by what is 4? 8 divided by 2 is 4. Okay, 12. 12 divided by 3. Okay, and 16. 16 divided by 4. So there, that one's lined up. 4 divided by 1 is 4. 8 divided by 2 is 4. 12 divided by 3 is 4. Same thing for 16 divided by 4. Okay, so now the next one, still using our whole numbers. So show 8 examples of pairs. Okay, so x minus y equals 4. So if I started with 4, 4 minus 0 is 4. Okay, and then let's just keep moving up. Let's go with 5. 5 minus 1 is 4. Okay, 6 minus 2 is 4. 7 minus 3. Now you're going to notice a pattern, okay? I'm just going up by 1 every single time. Okay, so 8, 9, 10, 11. So then 8 minus 4, 9 minus 5, 10 minus 6, 11 minus 7. Okay, there gives us our 8 values. Okay, so after you've done a few, you can see a pattern and you should be able to follow that pattern. Now, use a chart to solve this problem. Show 8 examples of pairs of whole numbers that can be substituted for x and y in the equation. X times 1/2 equals y. Okay, so let's start with 2. Okay, 2 times 1/2, which is saying 2 divided by 2, which is the same thing. Okay, 2 times 1/2 is 1. Okay, and let's say 3. 3 times 1/2 is 3 halves. 4 divided by 2 is 2. Okay, so in this case, it's actually going to be easier if we just used our even numbers. Okay, 6 times 1/2 is 3. 8, 4, 10, 5, 10, 12, 6. So if you're going to notice, if we just eliminated that 3 halves one, okay, we're going up by 2's here, and then up by 1's here. So we can just continue with that list. 14, 16, 18, 20. Okay, this would be 7, 8, 9, 10. Okay, this value, the x value, and then the y value should be half of the x value. All right, so there's lesson 5. Now you will need to take your quiz. So unit 2, quiz 1. Make sure you log on to Transmath and get that completed. If you have questions, let me know. Have a good day.